Okay, so today's topic is IPv6, Internet Protocol version 6. So why is the need of a different format of an IP address? IPv4 addresses are kind of depleting, means they are not enough for us to be used now. So what is the format of your IP version 6 address? Your IPv6 address is a 128-bit address. 128 bits. It's a 128-bit address written in hexadecimal format and separated by colons. So an IPv6 address is written kind of like this: 1111 1111 1111 1111. There will be only zeros and ones. So how do you do that? If I say 128 bits, your IP address, just a moment. Yeah, so your IP address, in your IPv4 addresses, you write octets like 1, 2, 3, 4, 5, 6, 7, 8. There are 8 bits in an octet of your IPv4 address. But here, this is a hextet. There will be 16 characters in one hextet, you can say. And after these 16 characters, for example, this can be a number like FFFF because it is a hexadecimal. So if I want to write 1111, then I will give it a colon. But this is a hexadecimal value, means actually it is in binary 0001, 0001, 0001 and 0001. After that it is a colon. So you might see an address like ABCD colon. So ABCD will be like here, if A is 10, 1010, 11, 1011, 12, 1100 and 13, 1101, like this. So this is a 128-bit address written in hexadecimal format and it is separated by colons. Your IPv4 address, IPv4, is a 32-bit address. It is written in decimal format, 1, 2, 3, 4 and 255 decimal format, and it is separated by dots. Here, this is separated by colons. And how many hextets will you have? You will have 8 hextets like this. So for example, this is my first hextet, 0001 colon 0002, 0003, 0004, 0005, 0006, 0007 and 0008. This looks a very huge number, and if you start writing in a bit by bit fashion, it becomes more huge because 10 in here is 0000, 0001. After that is a colon, 0000000010. Like this it becomes. Now, if an address is so huge, so how will you remember it? It is not very easy for a person to remember this address. So what they did was they gave you a shortcut that we'll talk about later on in a moment. But in your unicast, in your IPv4, you have unicast addresses, you have broadcast address, and you also have a multicast address. In IPv6, your broadcast is not there. You don't have anything called a broadcast in IPv6. Instead of broadcast, you have another term called anycast. What is unicast? Unicast is one-to-one. Multicast is one to a group. It's a group, and anycast is one to nearest. One to the nearest. In your IPv4 addresses, you cannot assign the same address to two same people on the internet. For example, sorry, not notepad. In your IPv4 address, for example, if I say I have to add an address over here on this interface, and I have 2 PCs over here. Now, on this interface, if you say, I have one IPv4 address that is 1.1.1.1, and this is connected to the internet. Anybody else on the internet will not have this same public address in IPv4. This is not allowed in IPv4. But this is allowed in your IPv6 format. Here you can have that same IPv6, and that is why it is one to nearest, and anycast is there. In your IPv4, if you go on an interface and assign it an IP address like this, after that you give him one more address. If you say 2.2.2.2, what happens is this 2.2.2.2 will be overwritten on this one. This goes down. But in IPv6 address, you can have multiple IP addresses on one interface. That is a very big difference in here. So let us see the very basic things of your IPv6. So unicast, multicast, and anycast. In here, there is nothing called the subnet mask. Subnetting is not there, you can say. So no worries about slash and all. But here, you don't write 255 like that. You have the slash notations only. So if I want to say that I have this address, this part of the address is my network portion. So I will say, okay, this is /64. Actually, this is a 128-bit address. Half of it will be 64. So after the address, you have to give the slash notation. In your IPv4, you are supposed to give the subnet mask, but here there is no subnet mask. Here you have to give the slash notation. The other thing in IPv6 is they gave you a very nice chance that, for example, if I give you a number, it's 2001 colon 0000 colon 0000 colon 0000 colon 00A0 colon 0000 colon 0000 colon 0001. This is which one of those three squads, 8 octets, 8 hextets like this. What they said was you can omit the preceding zeros. Anytime you see a number, for example, if I say 00100, this is $100. So no point of writing zeros before it, right? There is no value to a number before this. So you can omit these preceding zeros, but you cannot omit these zeros, right? These zeros after a number, a zero cannot be omitted. Before it can be omitted. So how will you write this number? You will write this number like that. 2001 colon 0000 colon 0000 colon 0000 colon A0 colon 0000 colon 0000 colon 0001. And here you can also omit this because these are preceding zeros. The previous zeros can be omitted. So they said, again, the makers will say that, why do you want to write 4 zeros? Or else, what if there are continuous zeros? What if there is a continuous set of zeros, contiguous? You can write it like this, 2001 colon colon. If you write 2 double colons over here, means in between these double colons, there are all zeros. So again, this is the shortened expression you can say. So how will I write this? A0. Again, colon colon and 1. But this is wrong. Why? Because if I don't show you these numbers, if I don't show you these numbers and and if I write it like this, if I don't show you these 2 digits and I tell you to tell me what is this address exactly. There are 8 hextets. Do you see 2001 colon 0000 colon 0000 colon A0 colon 0000 colon 0000 colon 0000 colon 000. This is actually confusing the device. Your device does not understand that where is the exact zero. So that is the reason they said, if you have, just a moment. So they said if you want to have continuous set of zeros, you can do it only once. If you do it on the second time, you have to write it like this only. Then only your device will be able to make out that there are, now the previously it was 2001 colon 3 times 3 hextets of zeros were there, colon A0 0000 colon 0000 colon 0001. So now the device will be able to figure out there are actually 8 hextets. So okay, 1 2 3 4 and 5. So I have 3 over here, 6 7 8. So if you want to omit continuous zeros, you can do it only once. Sorry, yeah, this was over here. So what if you say that there are all zeros in between? There are all zeros. So you can simply write it like this, 2002 for example, colon colon 1. Means the device will understand, okay, how many are there? There are 2 only. Means in between 2002, there are 6 hextets like these 0. 1, 2, 3, 4, 5, 6, 7, and there will be one more. Sorry, I omitted 1, colon 00, 0 1, like that. Okay, so if you say there is a contiguous set of zeros, you can write 2 double colons, but you can do it only once. The second time you have to write colon colon A0 colon 0 colon 0 colon 1, like that you will have to write. So you can omit it only once. The next time you have to write a single 0 instead of that. So if I say this was somewhere over here, A0, and it will look like this. So 2002 colon colon 3 hexadecimal of zeros, then A0, then colon 0 colon 0 colon 1, like this. Now if you say, you saw DHCP yesterday, right? There are all 0.0.0.0, right? DHCP uses 0 zeros for itself. Yesterday we saw it. So in here, double colon is reserved for your DHCP discover message. So if a device wants to go and take an address from the DHCP, he will have all zeros as his source address. So a double colon is reserved for DHCP discover message, right? You have your public addresses. Your public addresses should start from FC or FD over here. Okay, these are known as your site local addresses. Public addresses or private addresses, site local equals to your private addresses in IPv4. If you see APIPA, remember 169.254. So APIPA will be your FE80. If any number, if any IP address starts with FE80, means this is called your link local addresses. You can, this is like your APIPA, link local addresses, and you will see your global addresses starting from 2. Technically it starts from 2, 000, as far as I suppose it should be 0001, and it will go till 3FFF. This is the, you can say, globally unique addresses. So on the internet, all the addresses should start with 2 basically, and then it should go like this. In your IPv6 addresses, in your IPv4, your loopback is 127.0.0.1 till 127.255.255.254. This is the range reserved for loopbacks in your IPv4 world. In here, it is only one number, colon colon 1. This is your IPv6 loopback equals to your loopback testing. So they said, why do you want to waste a whole chunk when you can test it? The only testing is one number. If one number pings back, then it's good. CMD cd/cls ping colon colon 1. If you say, this is testing your network adapter. So we used to ask earlier, right? What if your loopback does not give you an answer, or how will you check your network adapter is working? You need to ping your loopback address. If your network adapter has the IP stack enabled, now if your adapter has IPv6 stack enabled, then it will give you an answer. And it's like from 2000, the millennium started. From then it has all this. You can see all the adapters are IPv6 enabled. So it will give you a reply always. So if I ping colon colon 2, it will not give me a reply because it is not reserved for testing. You can say only this one digit, one IP address is reserved for testing purposes. So how will you design, how will you do the application of this one? And one more good thing about is, one more thing to understand in IPv6 is, whenever you enable IPv6 routing on your, or anytime a device has an IPv6 capability, it uses the link local address. Automatically it generates a link local address without you specifying. It's called EUI-64. Simply what it will do is, it will take the MAC address. For example, the MAC address is globally unique on your adapter, right? Just think of it that your MAC address is 11-11-211 and 222222. This is your universally unique MAC address. Now what will your adapter do is, it needs 128 bits of your address. So half of the address it has /64 it knows. Why? Because /64 is FE80, that is fixed, colon colon. So half of the address it has, it needs the other 64 bits. Now your MAC address is 48 bits. MAC address equals to 48 bits, and the requirement says we need 64 bits more. We need 64 bits to add to FE80. Now so we need 16 more bits. Now what will we do is pad FFFE to the MAC address. Now where will you pad? That is another question. Half of the address and half of the address is separately assigned, IEEE and vendor assigned. So in between over here, you will do that. So what will we do? How will this look like? This address will look like, so on the half portion here, on the half side here, this is half and the other is the other half. So in between this number, you will pad FFFE. How does it look like? Here, FFFE, FF, and here, this side is FE. This number is fixed. Now, first of all, let me show you to your notepad. Let us do this. First of all, this is 1111. This hyphen will be removed, so it becomes 11-1111. This is 448 bits. So IPv6 is a 16-bit. So that is why these two octets are combined, you can say, right? 16 bits, we got 16 bits over here, hexadecimal values, MAC addresses. After that, you write a colon, then you say 11, and then FF. Okay, added in between 1111, 6 times 1 and FF, then again FE, and this 22 will come into picture. 22, sorry, over here, 22, colon 2222. Simple as that. It's 4, or else you can take a different approach also. 1111 colon 1122 colon 2222. This and this is the same. You can write it in a octet format or a hextet format, you can say. Just combine these two numbers, simple as that. 16 3s are 48. This is a nibble, you can say. So that is why it is 4 bits. It is a hexadecimal value. So what we can do is we can write it like this, and in between we will pad FFFE. But what they said was you have to flip the 7th bit. Why? Because the 7th bit in your MAC address will tell the receiving, will tell that is this address a globally unique address or it is a locally used address. So now the thing to understand in this is your MAC address, and this MAC address is a hexadecimal address. So if I want to write this hexadecimal into binary 0001, this is actually how it is written. It looks 11 and 11, but it is actually a nibble. It is a hexadecimal value. So they said you have to remove the 7th bit. So if the 7th bit is on, you have to turn it off. If it is off, you have to simply turn it on. Flipping means you will see this is 0001 0011. I am just going to turn it on if it is off. So now what will I do is simply take this address, see, simply FE80 colon 1, and this is 3. This is 3. So 1 3 I will write 1 3 and then 1 1 colon 1 1 FF colon FE 2 2 colon 2 2 2 2. It is very simple. I will show you one more example. Just see what we do. See, just taking a real example. What I'll do is I'll take a real example. Just give me a second. So this is our question. This is your real life question and here is your answer. But let us see how do you get this type of answer. Let us see that what is the address over here. What is the address? It is 00-50-50 hyphen 56 hyphen C0 hyphen 00 hyphen 02. This is your MAC address. सबसे पहले what you will do is you will make it into four parts. Simple. 0050 colon 56 C0 colon 0002. What did I do? I just added these two together because I want 16 digits and this is a hexadecimal value. So I combined these two octets over here, 1, 2, and these two over here and these two over here. Okay. Now in between over here, I will add FF and FE. So the next thing will be 0050 colon 56 FF colon FE C0 colon 0002. I got my 64 bits, unique 64 bits, but I need to flip the 7th bit now. So my 7th bit is in this one, right? 7th bit is in this one, 00000000. It's like this, and it's like 010. It's 4, right? Okay, no worries about that. 0101. It is 5 and 0000. This one hextet looks like this actually. So this is my 7th bit. I'll just take this out. Yeah, this is my 7th bit. I'll flip it like this. So in here, what is the actual value? So this will become 0 and this becomes 2. 0250 colon 56 FF colon FEC0 colon 0002. Simple as that. And if I say I want to write it over here like this, I will say FE80 colon. Now this preceding zeros will be gone, so I will write 250 colon 56 FF colon FEC0 colon 2. And after that, Microsoft will add something called a percentage sign over here. But understand that this is not your IPv6 address. This is not a part of your IPv6 address. That is just for Microsoft to use. So don't think that this is an IPv6 a part of, just this is your IPv6 address. Now let us compare this with your answer. Sorry. Okay. So what I'll do is I'll simply match this one. Let us see. FE80, correct? FE80 over here. 250 colon 250 56 FF FEC0 colon 2.